Statistical Rethinking, second edition, chapter 14, and we're just starting the medium difficult questions. We're on 14M1. I think I need another hashtag there. Okay. So what we're going to do here is we're going to repeat the simulation and analysis that took part at the very beginning of this chapter, where we had a robot go around trying to decide how long it took different cafes to serve coffee at different times. And if you remember, this chapter is dealing with situations where the different parameters, in this case a slope and an intercept, are connected somehow, that there's some kind of correlation between the parameters. Okay. And so we're going to consider that as we're going forward here. Okay. Now, so what we're going to do here is we are going to set that relationship between the intercept and the slope, and that relationship, that correlation, is called rho. Okay. We're going to set it to zero correlation, to no correlation. And then we want to see how the posterior distribution of the correlation of rho reflects the change in the underlying simulation here. Okay. So the first thing I'm going to do is I'm just going to completely copy and paste what we did at the first part of the chapter. Okay. So I'm just generating data, but notice that I'm leaving rho at negative 0.7, and this will allow us to compare what happens when we change that value to 0. Okay. So I won't go through everything here, but basically we're just setting up data where the parameters, the intercepts and the slopes, are correlated by negative 0.7, and then we go through and we make a covariance matrix. You really should read the first part of the chapter, or the whole chapter, to get a sense of what's going on here. That's all we're doing. Again, just generating data where the slopes and intercepts are necessarily correlated by negative 0.7. Okay. And then we run the model, and this is just the model that was done in the chapter. Okay. Again, I haven't done anything different. Copied and paste. And so with this, we're going to extract the posterior, and then we're going to look at the posterior for rho. Okay. For capital R rho, the model's estimate of capital R rho. Okay. And then we're going to repeat that, but now in little r rho. In other words, this value, the value we use to generate the data, not our estimate of rho. Okay. We're going to set that to 0. So I just have that same code, but now I have rho equals 0. Okay. And I've already ran this, and I don't want to run it again just in case something gets screwed up. But we've run that. So now we have a new data frame. Okay, that incorporates the no correlation in the data generating mechanism for A and B. Okay, and then I run the model again, exactly the same model, but it has a different name, and I extract the posterior so I can look at the posterior for the estimate capital R rho. Okay, I guess it's already shown down here. Okay, so now I'm just going to have the density plot for the initial estimate, okay, as well as the new estimate. Okay. And I've also drawn lines at the prior values for rho. Okay, and so this is what you get. So, when we had the prior set to negative 0.7, so there's negative 0.7, we saw that the posterior estimate kind of drug the estimate for rho to the right. Okay. And then when we set it towards 0, it looks like it peaks at 0, although it looks to be a little bit skewed to the left. And so probably it does matter. But in other words, what is happening here, so why is this one not peaked exactly at negative 0.7? But this one does seem to be peaked exactly at 0. Well, that has to do with the function of this LKJ correlation matrix. What this does is it makes the model suspicious of strong correlations, close to -1 or close to 1. Okay, and so when you get data that actually has correlations, closer to -0.1, towards one extreme, the model is skeptical of that, and so it pulls it back towards the center. But then when you get a prior that is, right in the middle, as far from extreme as you can be, it doesn't really shift the prior that much. Okay, I'm sorry, doesn't really shift the estimate that much away from what we know the data generating mechanism to be. Okay, so I hope that makes sense, and we'll call that good.